Hello, my name is Neville Palmer, and I want to talk about the automation of a computer networking laboratory. So I'm going to look at the use of the laboratory in education, and then the needs and benefits of automation of the laboratory, and then how this was accomplished using PowerShell scripts, and how these PowerShell scripts were aggregated into a graphical user interface, and then eventually how this can be used to inform the curriculum. So the primary users of the computer networking laboratory are the computer networking degree program, and there are 22 computers that are used by the actual lab itself, plus some others such as the master computer, which contains a master image of the computers in the laboratory, and some test machines. The computers are used to host virtual machines using VMware. So we have virtual machines for Windows XP 7, 2003, 2008, and Linux, for example, SUSE, Ubuntu, and Kali Linux. And we can also get the computers to talk to Cisco routers, switches, and ASA appliances and other hardware. But we also make use of simulation and modelling software such as Cisco Packet Tracer and GNS3, that's a graphical network simulator, and also Riverbed Modeler. And we look at operating systems such as obviously Linux and Windows, and the administration of those by using scripting and graphical user interfaces. So here's a typical example of one of those laboratories. We start off by configuring a DHCP server in Linux. We might do that using by editing the text file manually. And then we look at how this can be incorporated into a graphical user interface. So we might use, for example, Qt and C++, and using the contents of line edit boxes on a form, we use that to output the relevant information to a dhcp.conf file, which is a text file that stores the configuration for the DHCP server. So the challenges of using the laboratory are sharing. So the laboratory computers are shared amongst the number of different courses and different years, for example years 1, 2 and 3 of the computer networking degree program. And also configuration management is one solution to the problem of sharing. We might want to use configuration management to set the loopback adapter addresses on the computers in the laboratory. So for example, if we're using GNS3, we might want to be using the loopback adapters to talk to the hardware devices within GNS3. And also we might want to reclone computers or rebuild them, and I'll come back to that in a moment. We might want to shut down or restart them at various times of the day. So rebuilding or recloning. Well, rebuilding means that we maintain an image of each computer on a master computer, which is then uploaded to a Ghostcast, semantic Ghostcast server. So if we want to deploy that image to the computers in the laboratory, we do so using Ghostcast, and we can do this either one partition at a time, which is obviously the fastest method, or the whole disk, but that might take up to 60 minutes or more, whereas cloning just a partition might only take 15 minutes. If we want to reclone the computers, basically we use virtual machines, and we don't get the students to use the actual virtual machine itself. We use a linked clone, and we can rebuild those linked clones by essentially recloning them. So what are the requirements of automation? We obviously need to rebuild or reclone the computers in the laboratory, as I've just outlined above, and we might need to shut down the computers at certain times of day and restart them, for example, before starting a rebuild. We might want to schedule some of these tasks, and as I've mentioned before, we might want to set up the IP addresses on various adapters. We might also want to install software centrally from the server. We might also want to transfer folders that are stored on the server to the machines within the laboratory, and we might want to do this to selected machines, not all of them. So we started to do this using PowerShell scripts. So here's an example of one called set IP, which enables us to set the IP addresses on the loopback adapters on the computers in the laboratory, and we basically maintained a number of these PowerShell scripts to do different tasks. So the productivity and efficiency was improved with automation. With no automation, if we rebuild the computers with just one partition, it takes 15 minutes, and the whole computer would take about 60 minutes or more. And configuring loopback adapters, well, we'd have to configure them on the master PC, upload that image to the server, and then download it to all the computers. So that would take at least 30 minutes for just one partition. And we worked out that we're wasting 3,200 hours of wasted energy. But with automation, if we use recloning techniques on the virtual machines, that would take less than 1 minute, and we can do that centrally from the server. And configuring loopback adapters, once we can restore them from a pre-configured file on the server. That takes about 5 minutes. And obviously we're saving energy by also automation by shutting down computers. So the problem that we found with automation is that we ended up with, using PowerShell scripts, we end up with quite a large collection of PowerShell scripts that do different things. And it became difficult to customize them. So for example, if we wanted to change the IP addresses or the computers that we delivered a script to, we'd have to edit the files. This requires specialist knowledge to use the PowerShell scripts effectively. So the solution was to develop an application in which we can aggregate the scripts, and we can customize those scripts from within the application, and this made it much easier to use. So we used Visual C# to develop a graphical user interface to do this, and that allowed much easier use and customization. So here's an example of this is the remote configuration console, and just looking at the sort of one of the tabbed pages, that it uses tabbed pages to switch between various functions, and you can see here that this is the one that sets IP addresses on the loopback adapters. Over on the right hand side we've got a list of PCs. So here's an example of configuring the IP addresses on the loopback adapters in the laboratory. So you can set up the IP address, subnet mask, gateway, DNS server, and you can enable or disable them. Over on the right hand side we have a list of PCs. Computers that have got an XX next to them mean that they are either there's no connectivity or they're switched off. Ones with PC next to and their number mean that they are connected and visible from the software. So we can select those. We can select all or none of them, or selected computers to deliver this configuration to. This shows how the PowerShell scripts are constructed. For example, there's a function here called setAdapter, and this uses the contents of the text box on the form to construct the PowerShell script. We've got a number of strings here that we defined, so that if we just use one string, it would make it more difficult to see how the script is constructed. But if we use a number of strings, we can it makes it easier to demonstrate to students how the actual PowerShell script is constructed. So command 1, for example, is encrypting the password. Command 2 is configuring the user credentials, and command 3 is then locating the loopback adapter using the Windows Management Instrumentation class. And then command 4 is either enabling or disabling the adapter based upon whether the corresponding checkbox is checked or otherwise on the form. And then we're creating a new instance of a PowerShell script, adding those commands to the script, and then invoking that PowerShell script. Here's the second half of that function. So we're again locating the if the adapter is enabled, we're locating the adapter, then we're configuring the IP address and the subnet mask, and also the gateway and the DNS server. Then we're creating a new PowerShell script, adding the commands to the script, and then invoking that script again. Now you notice we've also got a string here called output, and that's being put into a text box on the form. Before we do that, we remove sensitive information like the username and password. because we might not want to share that with people that we're demonstrating the program to. But the text box would contain the constructed script, so it would be very useful to demonstrate how the commands are constructed to students. So there'd be a linkage between the software and the output, and that can be also used for testing, as we'll see later. And here's another example of part of the functionality of the remote configuration console. We can create a share on the server, and then we can put some files in there, and we can then deliver the contents of that shared folder to a particular folder on the destination PCs. So we can again select the PCs to send it to. And we could also do the same kind of thing to install software. And we can use Windows installer file with a .msi extension, and we can then use MSI exec to install the software on the PCs. And we could also shut down and restart, and we can reclone the computers. We could also randomize the MAC addresses, because if we copy computers from a master image, we tend to find that the VMware MAC addresses on the adapters will be the same, so that might cause us a problem. So we can randomize those MAC addresses. And we could also schedule some of those tasks. So we might want to do a shutdown at late at night, might want to do a daily reboot, we might want to rebuild those virtual machines at certain times of the day, certain days of the week. And we could also, the program also outputs to this text box that I showed you just now. This is the debug window, so we can take the contents of that text box and we can put it into a text file, and we can then run the command to make sure that it's working. So we can use this to test the PowerShell script, but we can also use it to demonstrate how the program itself constructs a script, and then we can then use that to demonstrate to students. So here's an example. Here's that same example which we put into a text file, which we can then run as a PowerShell script, and we can use this to demonstrate the usage of scripts to students as well. So the conclusions are that the laboratory automation has improved productivity, and educationally we've developed a series of PowerShell scripts and a Visual C# graphical user interface. And we've then combined that those PowerShell scripts and the graphical user interface to produce a user-friendly application that we can use to demonstrate to students. So what are the recommendations? Well, further development and improvement of the remote configuration console application itself would be beneficial. But as for its use in education, it's a very useful application to demonstrate configuration management tools and their development. And this is a very important part of network management generally. And also, what next? Well, PowerShell labs that demonstrate how to use PowerShell scripts would have to be developed further. And also at least one lab that would demonstrate how PowerShell scripts can be used within a Visual C# developed graphical user interface. And so the remote configuration console itself is a very useful tool for demonstrating this principle, and perhaps a simplified version of it could be produced so that it can be used for demonstration purposes for students. And also it would be beneficial to encourage students to perhaps pursue this as a topic for their final year project. So here are my references, and thank you for listening. Are there any questions?